Hi children, today I am teaching you the second chapter of your Icse physics syllabus for class 10, that is work, energy and power. Now what is work? The first topic we will learn today, that is work. What do you mean by the term work? What is the definition of work? If I ask you this question, you might be thinking every day you do lot of work, like you are studying, you are reading, you are writing. So after a long hour of class, you are feeling tired, you are feeling energyless. So might be you are thinking you are doing lot of work in everyday life. But physics says that all these are not work. As for physics, the definition of work is something else. So, what is work then? Work is said to be done when you apply a force on a body, and if the body moves, then we may say work is done by the force. So, what is the definition of work then? Please note it down now. Work is said to be done. Work is said to be done only when a force applied on a body makes it to move. Makes it to move. So this is the definition of work. Once again I am repeating, work is said to be done only when a force applied on our body makes it to move. That means whenever you apply a force on the body, if the body moves, then we will say work is done by the force. Say for example, if we apply a force on our body on a chair and the chair is moving, then we will consider work is done by the force. The different types of the examples of the work done are there. While you are playing in the field, you apply the force on the football and the football moves. That is the example of the work. And what if you apply the force on the body and the body does not move? Now, are you doing any work? No. At this moment, my dear children, you are not doing any work. Means, whenever you apply a force on the body, if the body does not move, then the work is not done. Say, for example, I am applying force onto the board. I am pushing the board. Now, I am applying a very huge amount of force onto the board. Is the board moving? Is it moving? No, it is not moving. Therefore, I am not doing any work, or the work done by the force applied by me on the board will be zero. So, therefore, the amount of work done obviously depends on two factors. What are these two factors? One is the force, another is, I have told you, it applied on the body makes it to move. That means the displacement. So therefore, the amount of work done depends upon force, and number two depends upon displacement. These are the two factors which are required for the work to be done. Therefore, the amount of work done is equal to the product of the magnitude of force and the displacement of the body in the direction of the force. Now we may write down the expression of work done from the definition, that is W is equals to F into S. So here W stands for work done, F stands for force and S stands for displacement. Now if S is equals to 0, that implies W is equals to 0. Why? Because work is the product of force and displacement. Since displacement is 0, I am not making force as 0, because Force is there. Force is applied on the body. But the body does not move. So therefore the displacement of the body is becoming 0. So at that moment work is 0. So once again I am saying you, when there will be no displacement on the body, by the applied force work done will be 0. So in this way we will measure the amount of work done. So the amount of work done is equal to the product of the magnitude of force and the displacement it produced in the direction of the force. Now if this is the magnitude of the work, now next topic is your what if the force is applied on the body and the body does not move along the direction of the applied force? Then are you doing the work or you are not doing any work? Obviously you may think, yes, we are not doing work, because you told that whenever force is applied and the body is moving along the direction of the force, here as per this expression, so you may consider, you may think that the work is not done. Yes, work is done, but in that situation we will be not getting the work, we will be not finding the work in this way. So in that situation, whenever the force is applied onto the body and the body does not move along the direction of the force, the body is moving in some other direction. In order to calculate the amount of work done, we have to find the component of the displacement along the direction of the force. Now, what is this component of displacement along the direction of force? Let us see this. Now, let us consider this is a body. So, this is a ball. A force is acting along this direction onto the ball, and the ball is placed at a point A. Now, the ball is moving along this direction, and finally the ball is reaching at this point. So this is your point C. Now in which direction the force is applied? You can see force is applied along this direction. So this is the direction of the applied force. In this direction the force is applied, but the body is moving along this direction, isn't it? Now in this situation, if the body covers a distance or displacement as S, that is from A to C, the displacement is S. How can you find the work done in this situation? For this we have to find the component of the displacement along the direction of the force. Now what is this component of displacement? We have to drop a perpendicular from the point C onto this axis, onto the direction of the force axis. So after dropping a perpendicular, say this is the perpendicular which I have dropped, say it is touching at point B to the direction of the force. Now the component of the displacement along the direction of the force is AB. So therefore, now as per the definition of work done, W is equals to F into AB. Let it be your equation number 1. Now how can you find the value of AB? See, this is a right angle triangle. ABC is a right angle triangle. Now the body say makes an angle theta while it is moving along the direction AC. So the angle between the direction of the displacement and the force becomes theta. So now how can you find AB? Think. Can you say me how can you find this value of AB? Yes, by using trigonometric ratio. Now which trigonometric ratio gives the relationship between hypotenuse, base and angle of the acute angle of the right angle triangle? That is obviously cosine theta or cos theta. That is, so in the triangle ABC, in triangle ABC, cos theta is equals to, what is the formula of cos theta? Cos theta is equals to base divided by hypotenuse. Which is the base? AB divided by AC. That implies AB is equals to, we'll find the value of AB. AB is equals to AC cos theta. That implies AB is equals to AC, the value of AC or the magnitude of AC is already given as S cos theta. Now substitute the value of AB. Say this is your equation number 2. Substitute the value of AB from equation number 2 in equation number 1. This is the equation number 1. What was the equation number 1? W is equals to, I am writing here, W is equals to F into AB. That implies W is equals to F into the value of AB we are getting S cos theta. So S cos theta. That implies W is equals to Fs cos theta. So this is the expression of the work done when the body does not move along the direction of the applied force. Obviously from this expression you are seeing that the work done depends on 3 factors. Before I have told you this depends on 2 factors when the body was moving in the direction of the applied force. But here when the displacement of the body is making an angle to the direction of the force, at that moment the work done depends on the magnitude of force, depends on the magnitude of the displacement and the cosine of the angle between the displacement and the force. So therefore here the work done depends on, we may note it down, work done depends on which are the factor? Number 1 the force, number 2 the displacement, and number 3 that is your cos theta. So now we will be discussing the special cases of this by taking the different value of the theta. We will see now when the angle is 0 degree what happened, when the angle is 90 degree what happened, when the angle is 180 degree what happened. See students, now we will see the special case. Now case 1 I have taken if theta is equals to 0 degree. Now theta is equals to 0 degree means what? When the displacement or the direction of the displacement is along the direction of the force, at that moment theta becomes 0 degree. Now say for example I am keeping a body over here, I am applying the force onto the body along this direction and the body is moving along this direction and finally the body reached at this point. So at this moment the direction of the force is along this direction and the direction of the displacement is also along this direction. So therefore the angle between the force and the displacement is here 0 degree. So at this time we consider theta is equals to 0 degree. So if theta is equals to 0 degree, then as per the expression of the work we know W is equals to what? Fs cos theta. So W is equals to Fs cos 0. Now W is equals to F into S, the value of cos 0 is 1. So that is equals to W is equal to Fs. Therefore we are getting positive work, or at this time the work done is said to be maximum, or we are doing positive work. So this is the case whenever you apply the force onto the body and the body moves along the direction of the applied force, that is W is equals to Fs. So what I have told you from the definition of the work is said to be done only when the force acts onto the body and the body moves. And there as per this we have given you the expression of the work done, W is equals to Fs. And I have told you here S is the displacement along the direction of the force. So if suppose the displacement produced along the direction of the force, then theta is equals to how much? 0. So did you understand why the first expression I have written W is equals to Fs, and I have told you also here S is the displacement in the direction of the force. That means when the body moves in the direction of the force, at that moment the work done is positive. We get positive work. Can you give me some of the examples of the positive work? Suppose when suppose a body falls freely under the action of the gravity. Say this is a body is falling now along this direction. Now what is the force? Now what is the direction of the force acting? Force is the force due to gravity, that is the weight of the body. So it is acting downward direction, that is your mg. Now what is the direction of the displacement? the direction of the displacement is also in the downward direction, S, and therefore work done by the against the force of gravity, by the force of gravity, work done by the force of gravity is positive, or maximum work is done by the gravity when a body falls freely under the action of the gravity. See once again, here this weight or the force of gravity is acting downward direction and the displacement is also downward direction. Therefore, the angle between the displacement and the force of gravity becomes 0 degree, and therefore the work done by the force of gravity W is equals to mg into S. So here we can consider how much work is done by the force of gravity. So W is equals to mg again into S cos theta, that is equals to mg. If this S or the displacement will become say height, suppose the body is falling from a certain height onto the ground, therefore the displacement will change into h. Now in place of S we write over there h into cos 0, that is equals to mgh. So this is the expression of the work done by the force of gravity on a body when the body falls freely, that is W is equals to mgh. So can you give me some other example of the positive work? So this is the case when the force acts on to the body and the body moves along the direction of the force. Suppose I am applying the force onto this duster. Can you see the duster? I am applying the force onto the duster, and the duster is moving along the direction of the force. I am applying along this direction, and the duster is moving along this direction. So at this moment the work done by me is maximum, or it is here positive, or the work done by the force applied by me onto the duster to move it is positive, that is here W is equals to F into S. Now move to the second case. So case number 2, what is that? If theta is equals to 180 degree, that means the angle between the displacement and the force will be 180 degree. What does it mean? It means that when you apply the force onto the body and the body moves in the opposite direction of the applied force, how it happens? I'll apply a force onto the body and the body moves in the opposite direction. Say I am pulling the duster towards me, like this I am pulling, and the duster has to move towards that side. So this is the case when we take theta is equals to 180 degree. But how is it possible? Is it possible? Yes, it is possible. I will be giving you the example. Before that, you understand this. So when theta is equals to 0 degree, that is, this is the case when we apply the force. Suppose this is a body. Now the force is applied onto the body along this direction. This is the direction of the applied force, but the body is moving along this direction. S is in this direction. So at this moment, the angle between the direction of the force and the displacement is 180 degree. So at this point of time, the work done W is equals to Fs cos theta, F into S, the value of cos 180 degree is -1. Therefore, W is equals to minus Fs. So the work done by the force is negative. During this moment, the work done by the force will be negative. Say for example, now I am throwing the duster in upward direction. When I am throwing the duster in the upward direction, the work done by me is positive, but the work done by the force of gravity will be negative. Why? Can you say me? Whenever I am throwing the duster in upward direction, I have applied the force onto the duster to move it in upward direction. So when the duster is moving in upward direction, it is moving by my force. So therefore the force is applied along this direction and the duster is moving along this direction. Now what is the angle between these two? Force is acting like this and the displacement is also is happening along the same direction. So the angle between the force and the displacement is 0 degree. Therefore I am doing their positive work. Now what about the force of gravity or gravitational force? Now when the duster is moving in upward direction, the force of gravity, the direction of the force of gravity is downward direction. So during that situation, the work done by the force of gravity or the work done against force of gravity on the duster will be negative. Any type of motion, when a body moves on a surface, the work done against the force of friction, as you know that the force of friction opposes the motion of the body. Opposes the motion of the body means the direction of the motion of the body in the opposite direction to that of the direction of the force. That is the case I have told you. Theta is equals to 180 degree. So theta is equals to 180 degree means when the direction of motion is opposite to that of the direction of the force. So when a body is moving on a surface, the force of friction opposes the motion of the body. Therefore, the angle between the force of friction and the displacement of the body is 180 degree. Therefore, the negative work is done during that situation. So next we will see, that is case number 3, if theta is equals to 90 degree. In which case you get theta is equals to 90 degree. Say I am applying the force, suppose this is the body, I am applying the force along this direction, but the body is moving along this direction. Now here the angle between the force and the displacement, this is the displacement, this is the force. Here theta is equals to almost 90 degree. At this time the work done, W is equals to same formula, that is Fs cos theta. So W is equals to F into S. Cos of 90 degree is 0. The value of cos of 90 degree is 0. Therefore, W is equals to 0 or no work is done. So at this moment, work done is 0 or no work. No work is done. So when the angle between the displacement and the force is 90 degree, at that time work done is 0 or no work is done. Now what is the example of this? How can we give this example? Suppose I am keeping this duster on my head and walking like this. So whenever I am keeping this duster on my head, the weight of the duster is downward direction, acting downward direction, that is the force of gravity. But the displacement of the duster is in forward direction, along this direction. This is the displacement of the duster. I am taking this like this. Now the direction of the displacement along this direction, direction of the force is downward direction. So what is the angle at this moment? This is the direction of the displacement and this is the direction of the force. This is force, this is the displacement. So the angle between these two means the displacement and force is 90 degree. Therefore, no work is done by the force of gravity, not by me. Here I am doing maximum work. Whenever I am going, I am applying the force onto the load to move. I am doing maybe work, I am doing positive work, but the work done by the force of gravity is 0. So here frequently in this part the question come in the ICSE, that is state the example when the work done is 0, or when a coolie is carrying a load on his head and moving in a horizontal path. What is the work done? By the force of gravity. So when a coolie is, suppose this is a coolie, this is a coolie carrying a load on his head. This is the load which is there on his head only. Now the coolie is moving along this direction. That means the direction of the load is this side and the direction of the force is acting downward direction. This is the direction of the force, that is your gravitational force. Because the direction of the weight means the force of gravity which is acting downward direction. So therefore the angle between these two will be 90 degree. Now 90 degree, that is theta. Theta is equals to 90 degree. Thus what is the work done by the force of gravity during this situation? The work done by the force of gravity is 0. No work is said to be done when a coolie carrying a load on his head and walks in the horizontal path. In the same way, if suppose the coolie is carrying the load and having the load on his hand and standing like this, what is the work done in this situation? In this situation also work done is 0. Why? Can you say me? At this time there is no motion, there is no movement, there is no displacement. I have told you before, when the displacement of the body is 0, at that moment the work done is 0. Here second we are getting another condition, we are getting when the displacement is 90 degree or the direction of the displacement is perpendicular or normal to the direction of the force, no work is done. So these are the two conditions for the work done. Now can you say me, when our body is moving in a circular path, so what is the work done? If the body is moving in a circular path, say now suppose this is the sun, this is your sun. Now the earth is revolving around this, so this is your earth, this is the earth. Now what is the work done here? The displacement or the direction of the displacement of earth at any point, suppose at this point is towards this side, tangent you have known, and the direction of the force, that is your centripetal force, is towards the center, therefore the angle between these is becoming 90 degree. So the work done by the gravitational force of the sun onto the earth will be 0 whenever the earth is rotating at any point. Now if a body is moving in a circular path, for completing one rotation, whenever the body is going round the trip or completing one rotation, at that moment the displacement is also 0 and therefore the work done is equals to 0. So you have to understand what it is asked to you. If in the question it is asked that when the body is moving in a circular path, so what is the value of work done? In that situation the work done is 0 because the centripetal force or the force of attraction of the center onto that body is toward the center, and the direction of the displacement of the body is like this, is a tangent which is drawn, and therefore the angle between these two will be 90 degree, therefore the work done will be 0. And when the body is moving in a circular path, for completing one rotation, suppose the body has started from here, again the body is reaching over there, body is starting from the point A, and after completing one round it is coming at this point. So what is the displacement? Here the displacement is equals to 0. Now do you know what is the displacement? This is the shortest distance between the initial and the final point of the body. So since this is the initial point and this is the final point after completing one rotation, therefore the displacement is equals to 0. If the displacement of the body is 0, therefore work done is equals to, we know, force into displacement, displacement is 0, so work done is 0. So in both the cases, whether the body is moving round the trip or the body is moving half of the circle or the body is moving in the quarter of a circle, during all the situations the work done by the gravitational force or the work done by the gravitational force of the sun onto the earth or the work done by the force which is acting at the center will be 0. So always remember that whenever the body is moving in a circular path, the work done is 0, whether it is round the trip or it is half of a circle. So now I'll say you another topic, how can you find the work done if the value of work is changing with the displacement. This is in all these cases I have discussed. When the constant force is acting onto the body, we can find the work done. What if the variable force is acting onto the body? How can you find the work done? If the force becomes variable. Now, when the variable force acts onto the body, the displacement also changes. Now, during that situation, in order to calculate the amount of work done, we have to plot a graph between force and the displacement. And the graph of the force and the displacement with the displacement axis gives us the amount of work done. Suppose whenever a force is acting onto the body and the displacement is increasing equally with the equal amount of force. I mean when the force is directly proportional to displacement. Here it is variable. The force is variable. The force is not constant. So I told you we can find by the graphical method, by drawing the graph, taking the force in this is your y-axis, this is your x-axis. By taking the force in the y-axis and displacement in the x-axis. Now when the force becomes directly proportional to the displacement, then it is come, or the graph will come a slope inclined to the displacement axis. It is a slope which is inclining to the, or it is a sketch inclining to the displacement axis. Now in order to calculate the work done, we have to find the area enclosed by the sketch, that is force displacement sketch, to the x-axis or with the x-axis or with the displacement axis. Now if suppose this is the sketch of a certain situation where the force is becoming directly proportional to the displacement. Now so this is the sketch. Now we will find the area. This is a triangle now. Now the area of the triangle gives us the work done. Suppose this is A, this is your B, and this is your C. Now the work done in this situation, W is equals to area of triangle. This is a triangle, that is ABC. That is equals to, how can you find the area of the triangle? That is half into base into height. That is equals to half into base. Base is which one? This is the base. That is on which axis? S, displacement, into height. Height is this one. Means that is the force into F. So in this way we find the work done, half into S into F. So this is the way to find if the amount of force is variable, or when the variable force is acting onto the body. Now if a constant force is acting onto the body and there would be the displacement, or the displacement is changing, in that situation how can you find? We can find in the graphical way also. So in that situation it will come, suppose this is the graph, force is acting along this direction and this is the displacement. Now a constant force is acting but the displacement is varying. Suppose the graph will come in this manner. This is the sketch. Say this is the sketch. Now the area enclosed by the sketch AB with the displacement axis gives us the amount of work done by this constant force. So now how can you find? Now drop a perpendicular from here to here. Now this is becoming a rectangle or a triangle, or a square. Anything will come. So the area of this rectangle, we'll take a rectangle. The area of this rectangle, say AB will give here C, and say this is D. The area of the rectangle ABCD give us the amount of work done. So here work done, W is equals to area of a rectangle. So this is the way how can you find the work done when the variable force is acting onto the body. So next I will discuss the units of the work.